Hi, this is Math 1650, and this video is going to be over chapter 3, and we're going to start the first section called 3.1. Now, if you're watching this video, we are going to start really using StatDisk, especially with data, and you're going to want to follow along on using StatDisk. And the best way to do that is to first have it open on your computer. So in another tab, just go to, let's type in www.statdisk.com, and it goes right to this page that looks now different. There it goes to this. You'll see a spreadsheet, and then there's different tabs up here that we will use. Depending on what we use, it's going to bring up different kind of boxes sometimes, and we'll go through them as we do look at everything. The ones we mainly use would be data at the beginning, and then analysis when we get into chapter 5 and 6 and so on, but we'll also use what we learn from the data tabs. And then data sets we'll bring in every now and then, which it's really just a set. You pick something, the pre-ordered data. So movie data, for instance, it has data that's already in here. We can do stuff, change stuff, delete stuff. It doesn't matter. Once we clear it, we can bring it right back in, and it'll be there again. Or we can start typing in data easily into StatDisk and type in data directly. So on your homework, when you get a data set, you can type in the data. It's going to save you a lot of time, because even if typing in seems like it takes a while, once you have it in there, it's usually really quick to do some of the calculations. Not only that, but you can also copy and paste it, which is easier. Alright, so let's go back to the file, keep that open. We're going to start looking at what's called measures of center, and we're going to also introduce symbols for each of these. You'll see me use both symbols and just writing out the name sometimes. If you see a Greek symbol, it's usually for a population. If it's not a Greek symbol, then it's for the sample. Now, for instance, the sample mean is next with a bar above it. The bar always means average. For a population mean, it's a Greek mu symbol. For a sample size, which is how many data points you have in a data set, it's a small n. Population size, which is how many people you have in the population, it's a capital N. Alright, so the measure of center. This is a measure that summarizes the central point of the data set. Central point of the data set. Okay, we will look at 4 of them: mean, median, mode, and mid-range. First, the mean, and the mean is one of the most common ones. This is the average of all data values in the data set. Okay. Now, the mean takes into account all values. You add up all values, you divide by the total. That's the overall basic idea of how you find an average. Add up all values, divide by the total. If you only have a sample, so you only have so many of the population, let's say the population's 4 million, you only took a sample of 2,000, then it's a sample mean. If you took what was able to get every value for the population, then you look at the population mean. Okay. Now, a lot of times what we want to see in statistics is we're going to use the sample to basically describe the population mean. But there are some instances when the population is small enough. Let's say at Zane State, the population of Zane State students is probably small enough to get almost everybody. Okay. Now this symbol here, it means sum. So all this is saying is sum every data value up, every x value up from 1 to your sample size. So this is total data value sum over total number of data values. So that's for the sample. This is basically the same meaning. This is for the population. Okay. So let's look at the mean of an average roll and a normal 6-sided die. Okay. This would be a population mean. Okay. We know the die has 6 sides. That's the population size, 6. So it would be the summation from side 1 to side 6. So 1 plus 2 plus 3 plus 4 plus 5 plus 6 over the 6 sides. So that'd be 3, 6, 10, 15, 21 over 6, which is 3.5. That is your population mean there. Okay. Now, things get a little bit different when we have to look at a frequency table. We don't always have the raw data. And it's not always easy to find the mean itself just by doing simple calculations. Sometimes we'll have to use other like StatDisk and other tools because we just have so many data values. In this frequency table, we have 78 data values, and we had to find the total for these. And we only have the IQ, in this case it's IQ ranges for each set, so we don't actually have the raw data, so we use the midpoint. And so we take the midpoint for each one of these and we multiply it by the frequency. So 59.5 times 2, 79.5 times 33, 99.5 times 35, 119.5 times 7, and 139.5 times 1. And then we're dividing it by the total, which is going to be dividing it by 78. Now we can see here in this last column, they added up everything. I mean, what they did in this last column was that multiplication. 2 times 59.5 is 119. 33 times 79.5 is 2,623.5, and so on. Right, so the total here is 7201 over 78. And that ends up being a mean of 92.3. Okay, so that's how you would find the mean. And it's a little bit of an estimated mean because we don't have the raw data. That's how you find the mean using a frequency table. Then we have what's called weighted means, and that's when we have certain values that stand per score in a sense. So let's say we are trying to calculate our GPA based on 5 classes we've taken. We took statistics, got a C. We took biology, got an A. We took English, got a B. Keyboarding, got an A. And public speaking, got an F. Okay, and we wanted to find the GPA for this. So to calculate the GPA, we are going to multiply the credits by the weight of the grade. So an A is 4, a B is 3, A is 4 again, a C is 2, and an F is 0. So we're doing 2 times 3 plus 4 times 4, that's for the A, plus 3 times 3 plus 4 times 1 plus 0 times 3. And we're taking this out of the total number of credits, which would be here 7, 10, 14. And so we get 6 plus 16 plus 9 plus 4, and 0 times 3 is 0, over 14. So it would be 29, 35 over 14, which is looking after that semester at a GPA that is 2.5. So that's a third way of calculating a mean, depending on how the data is presented. All right. Now, for the median, it's the next measure. This is the middle number in a sorted data set. Middle value in a sorted data set. Okay, and it has to be sorted. You can't just take the middle number of how it's listed. It has to be sorted. It depends on whether you have odd or even numbers. That's really the only difference with these two examples we're going to have. So we'll sort the data values. So 0.42, 0.48, 0.66, 0.73, 1.1, 1.1, and 5.4. And then the middle number, so we have 3 on this side, 3 on this side, your middle number is 0.73. Alright, so this is the median. Okay. Odd numbers, there's one specific number in the middle, so it's pretty easy. Even numbers, what we do is, again, we sort the data values. So 0.42, 0.48, 0.73, 1.1, 1.1, and 5.4. And instead of having the middle number, we have the middle two numbers. We just take the average here. So 0.73 plus 1.1 over 2. That'd be 1.83 over 2, which is 0.915. Okay. Pretty straightforward. We're going to see that it gets even easier when we start using StatDisk for these. Okay. Now we'll get into mode. Mode is the most frequent data value. Bimodal means there are two different data values. That are repeated equally and most frequently. bimodal is there are more than two different data values that are repeated equally and most frequently. And no mode means no repeated data values. Now, one of the things with the mode is sometimes we're looking specifically at just the data values themselves, and we do that a lot when we have small data sets where values can be repeated a few times, but they're kind of still very small. Other times, especially when we have big data values, big sets, we look at the classes and see which class is repeated the most. All right, determine the mode of each of these. So we're looking for repeated values. Here we have 1.1, 1.1 that repeats, and that's it. So this is a mode is 1.1. And the next one, 27 repeats 3 times, 55 repeats 3 times, 88 repeats twice, so the mode is 27 and 55. Here 1, 2, 3, 6, 7, 8, 9, 10. No repeats, no mode. Alright, the mid-range. Found by averaging the minimum and maximum values. So the mid-range is the min plus the max over 2. Okay, don't get this confused with the range, which is the max minus the min. Okay, so there's the difference here. Now, before we move on with this, a couple of things I want to mention. One, our average takes into account every value. Because of that, if we have outliers that are either really small or really large, that average can be pulled maybe too high than it should be. The median doesn't take into account every number. It takes into account only the middle 1 or 2 numbers. But it's not really pulled because it doesn't take into account outliers. Right, we'll see later that the median isn't the best for a to estimate a population value, but it also isn't drawn far away with the min and max being outliers. So it is good at determining whether something is what we call a normal distribution. It just doesn't help with predicting the median of a population. The mode also kind of takes into account all values. If you think about it, it looks at all values. It's going to be pretty much the center, but it can be thrown off in small data sets if there isn't anything repeating and whatnot, and so you may not end up with a mode at all. The mid-range takes into account only 2 values, and they are probably the worst 2 values to take into account because they can easily be outliers. So if anything is going to be thrown off, it will be the mid-range. Alright, so doing this on StatDisk. Okay, so on StatDisk, type into 2 different columns the McDonald's data and the Jack in the Box data. These are drive-through times, and when we do this, I want you to keep the data set in StatDisk, throughout the next couple of videos, because we will still use the same data set for other things. Right, so let me type it in as well. I'm actually going to also name these. Last time I tried to name stuff, it didn't take. McDonald's, Jack. There. And type this in 287 128 92 267 176 240 192 118 153 254 193 136. So there's 12. Yep, 12. Let me just double check, make sure I got them all. If you miss one, you can just put it on the bottom of this. It won't affect anything. Okay, now we'll do Jack in the Box. 490, 229, 74, 377, 300, 481, 428, 255, 325, 270, 109, and 109. Okay, so now I have the data in here. Now, to find the measures of center, okay, we will enter the data into columns. We did that. Select the data tab, select explore data, select the column. Right, so data, explore data, descriptive statistics, basically what it also says. And then select the column. So we'll start with McDonald's. And we see the data here. Mean is 186.33. Median is 184. The mode we'll get to. The mid-range is 189.5. For the mode, again, we can look at the class. It would be these go from 50 to 150 to 250. So it'll be 150 to 250. That's one way of looking at it. We can also look at it and go back to the data and how many things repeat. I don't see anything that actually, let me look at the actual raw data. So I'll sort it. Yeah, and nothing repeats. Right. So we can say no mode on this, or we can say, the class 150 to 250. It's a large range for that, but it may make more sense looking at it that way. But let's look at Jack in the Box now. So again, data, explore data, then column Jack, and we'll get the mean of 262.25, the median of 262.5, and the mid-range of 277.5. And then the mode, in a similar sense, we can look at the class from 100 to 300. or we can look at any repeated data. So we'll sort it based on that second column, and we see 109 gets repeated twice, and that's it. All right, so first, before we get to comparing these, when you do your project, I would want you to look at it through class, because it's going to be enough data to do that. In this case, it makes a little bit more sense. The class for the McDonald's falls where what we see with the mean and the median and the mid-range are kind of right in between. And same with the class for Jack in the Box. It's 100 and 300, and all the mean, median, and mid-range are right in between. It's just the mode isn't as helpful right now in these small data sets. Right, so we're going to compare now the two samples. For Jack in the Box, it looks to take longer since all the measures of center are higher. The drive-through at Jack in the Box takes longer since all the measures of center are higher. I mean, we're talking around 262, which is about 4 minutes and 22 seconds compared to just over 3 minutes. Right, so about a minute longer. Right. The only one that doesn't work show this is the mode. Again, because we have a large range, it does have overlap there, but then also if you look at just the number that is repeated, one doesn't have a mode. So why would this information be important? To look at various aspects such as efficiency, the drive-through efficiency, customer satisfaction, and competitive advantage. McDonald's can kind of promote that they go faster. All right. Now we'll keep this data. We're going to use it in the next section as well. But we're going to continue with a new problem. Here, the given frequency distribution describes the speeds of drivers ticketed by a town of Coshocton police. These drivers were traveling through a 30-mile-per-hour speed zone. How does the mean compare to the posted speed limit of 30 miles per hour? Right, now this is a frequency data point, so what we're going to do is use the midpoint times the frequency. Now to do this on StatDisk, we have to type in how many times that number comes up. I'll show you a quick way of doing it. Let me call this I'll do it speed, something short. It doesn't want the title in now. Try it down here. Right, well, for some reason it's not putting the title. Alright, so we'll start with the data set. We have 25 values of 43.5. So we'll type in 43.5 5 times. Gotta use some modification here. Then we'll highlight it now. I've always found highlighting it from the bottom is the best. Control C to copy it, and then Control paste 5 times. And you get 25 in there. You can do it pretty quickly. 47.5. I'll just go halfway through in this one. 1, 2, 3, 4, 5, 6, 7, and then just copy and paste it once. Make sure you don't copy accidentally the 43.5 there. And we're at 39, which makes sense. 14 and 25. Then 51.5. We'll do it 3 times. Copy it. And again, 51.5. And then the last one, we're just going to type in 55.5, 55.5, 55.5, and 59.5. Okay, so we got all 50 now in. Right. And we're going to find the mean. So explore data. Select column 3. And our mean is 46.78. So what does this mean? Well, the people caught speeding are well above the speed limit. Right, so maybe that doesn't mean people don't go 30, 35. They just don't get ticketed. So now let's look at blood pressure measurement. We have 14 different second year med school students at Bellevue Hospital. They measure the blood pressure of the same person, and the readings are listed below. Right. We're going to type this data in. So let me go back now. Doing column 4. 138, 130, 135, 140, 120, 125, 120, 130, 130, 144, 143, 140, 130, and 150. So that's 14. Okay, I'm going to sort it first. Sort based on column 4. And we're going to see what the mode is here. 130 3 times. So the mode is equal to 130. And we'll go into the data. Column 4. Mean is equal 132.92. Median is equal to 132.5. And mid-range is 132. Right. So your center is around 132 or so. Alright. Let me go back. No problem. Last problem, we're going to have 2 more data sets we're going to enter. Jefferson Valley Bank and Providence Bank. Well, how they do it at each bank is Jefferson Valley, you're going to have all customer enter a single line, and then as that line, people up front of the line get to a teller, or a teller opens up they move into that teller spot. Whereas Providence Bank, each teller has their own line, so there's individual lines, and you have to choose what teller before you enter a line. And these are the times of waits that have been recorded. Alright, so we're going to get each of these into a stat disk. Now I'm going to add a column. So add column, just add one column. So there's a total of 6. And we have 6.5. I'm just going to do both data sets now. 6.6, 6.7, 6.8, 7.1, 7.3, 7.4, 7.7, and 7.7. 3, 6, 9, 10. I missed one, I think. 5, 6, 7, 8. 1, 3, 4. Oh, 3, 7.7. So I missed the last one. Alright, and then the other bank line 4.2, 5.4, 5.8, 6.2, 6.7, 7.7, 7.7, 8.5, 9.3, 10.0. Alright, let's go to data. Actually, first let's look at the mode for each of these. So for the first one, the mode is 7.7. So Jefferson Valley mode is 7.7. For the next one, Providence mode is also 7.7. They repeated twice. Now let's go to the data set. Column 5. Okay, so for Jefferson Valley, your mean is 7.15, median is 7.2, mid-range is 7.1, and for column 6, mean is 7.15, median is 7.2, mid-range is 7.1. Okay. So what we noticed with these, and that is measures of center are exactly the same. They all average around 7 or so minutes for a wait time. Right, even the mode is in green with that, maybe a little higher. Right, so what's different between these? That's going to be what's called a variation. Difference between data sets is their variation. And that is what we'll look at in the next video. Right. Again, keep this data, all 6 data sets. We'll be using them all, I believe them all, in the next video. See you then. Bye.